You know that feeling, right? You finish a crazy sprint, a really tough workout, you've completely stopped, but you're still just gasping for air. We've all been there. But have you ever stopped to wonder what's actually going on inside your body? Well, today we're going to dive into the science behind that very feeling. Yeah, this is the big question, isn't it? The race is over, the weights are on the floor, you've given it your all. So why do your lungs and heart feel like they're still going 100 miles an hour? It's like your body totally missed the memo that you're done. Well, turns out it's not ignoring you. It's actually busy doing a really important cleanup job.
Okay, so to get to the bottom of this, we've got to look deep inside your muscles. See, during that all-out, high-intensity effort, they ran into a pretty serious fuel problem. And that problem, well, it created a nasty little byproduct that's basically the culprit behind this whole thing.
So think of your body as having like two different energy systems. You've got your normal, everyday mode. It's slow, steady, and super efficient, using oxygen to make plenty of energy. But when you go into an all-out sprint, you don't have time for that. You need energy right now. So your body flicks a switch and goes into its emergency power mode. That's anaerobic respiration. It's incredibly fast and it doesn't need oxygen. But, and this is a big but, this emergency power comes with a price.
And here it is, the price you have to pay: lactic acid. This is the messy stuff that's left over from that super fast oxygen-free energy production. As it starts to build up in your muscles, well, that's when you feel that familiar burn. And more importantly, it actually starts to prevent your muscle cells from working the way they should. It's literally the reason you just can't sprint forever.
All right, so your muscles are just flooded with this stuff, this performance-killing lactic acid. Game over? Not quite, because this is where the hero of our story makes its grand entrance. Oxygen is about to come in and clean up the entire mess that sprint left behind. And the way your body handles this is, it's actually pretty amazing. Oxygen comes in and basically neutralizes the lactic acid. It breaks it down into three things. First, water, which your body can use or just get rid of. Second, carbon dioxide, which, you guessed it, you just breathe out. And third, a little bit of glucose. Yep, more fuel that your body can use again. It's like the body's own perfect little recycling program. Okay, but here's the catch. That whole cleanup process, it requires a ton of oxygen. And this, right here, is the core reason you're still panting for air. Think of it like this. During that sprint, your muscles basically took out a high-interest loan to get energy fast. Now that the sprint is over, your body has to pay that loan back. And the currency is oxygen.
And yeah, this whole concept actually has a name. It's called oxygen debt. It's literally the total amount of extra oxygen your body now has to take in to clear out all that lactic acid and just get everything back to its resting state. You spent energy you didn't really have, and now it's time to settle up.
Now, there are two key terms here that are really closely related. You've got oxygen debt, that's the amount you owe. Think of it as the bill itself. Then you have the process of actually paying that bill. That's called EPOC, which is short for excess post-exercise oxygen consumption. So one is the what, the debt, and the other is the how, the process of paying it. And here's the real takeaway, the thing that connects it all back to the beginning. That heavy breathing, that pounding heart you feel long after you've stopped moving, that is EPOC in action. That is your body paying back the debt. Your lungs and your heart are working overtime to pump all that extra oxygen through your system to get the cleanup job done.
All right, so now we know why we're gasping for air after a workout. But that leads to the next big question, right? Can we get better at this? What exactly determines how fast you can repay that oxygen debt and get back to feeling normal?
So, what exactly can speed up your recovery? Let's take a look, because not everyone recovers at the same pace. And if you understand the why, you can actually start to improve your own recovery time. It turns out there are a bunch of factors at play here. Your overall aerobic fitness is a huge one. I mean, a stronger heart is just a more efficient pump for all that oxygen. Your strength level matters too, because stronger muscles are better at actually using the oxygen they get. Then you've got things like genetics. Yeah, some people are just built for quicker recovery, plus age and gender. And never ever underestimate the power of good sleep. That's when your body really gets to work repairing itself. Okay, so if you're going to remember just one thing from all this, let it be this. When you do intense exercise, your body builds up an oxygen debt to deal with all the lactic acid. And that heavy breathing afterwards, that's EPOC. It's just your body working hard to repay that debt. Simple as that. And that kind of leaves us with one final thought to chew on. Now that you know exactly what's happening, the whole debt and repayment process, how can you use this? How could you maybe engineer your own recovery? By focusing on things we talked about, like improving your aerobic fitness or just getting better sleep.
How much more efficient could you get at paying back your own oxygen debt?